All right, let's just jump right in. We all learn that the universe runs on these fixed, unbreakable rules, right? The laws of physics. But what if that's not the full picture? What if the very rules that write the story of our reality aren't quite as real as we've always been told? That is the massive question we are digging into right now.
In this quote from physicist Sankar Das Sarma, it is the perfect metaphor for what we're about to do. We're going to peel back the layers of how we understand the universe, and trust me, you are going to be surprised by what we find at the center of this cosmic onion. You know, for most of human history, this has been the bedrock idea. The assumption that there's some kind of cosmic rule book out there, written in the language of math, that controls every single thing, from an apple falling from a tree to the way galaxies waltz across space. It's a really comforting thought, isn't it? That everything is part of an orderly, predictable plan.
But how solid is that bedrock, really? Let's start by putting that core belief, our so-called unbreakable physical laws, under the microscope. So, here's the thing. There are two totally different ways to think about this whole laws of physics business. On the one hand, you've got what's called the Platonic view. This says the laws are perfect, real truths that exist somewhere out there, completely separate from us. Our job is just to find them. But then, on the other hand, there's the descriptive view, which argues these laws are really just our own inventions, powerful mathematical tools that we keep improving as we learn more about the universe. We don't discover them, we invent them.
And this quote from Sarma just nails that second view. He's basically saying our laws aren't the territory itself, they're the map. And a map is just a representation, right? As we explore more of reality, our map just gets better, more accurate. Newton's map was amazing for its time. Then Einstein came along and drew a better one, and who knows, 1,000 years from now, our map will probably look completely different.
And get this, even our most rock-solid maps, like good old Newtonian physics, have weird little cracks in them. We think of it as this perfect clockwork machine where everything is predictable. But there are these wild thought experiments, one is called Norton's Dome, that show it's theoretically possible for something to just start moving all on its own, with no force at all. It's a flaw in the perfect machine, a hint that even Newton's laws weren't as perfectly deterministic as we thought. Some unpredictability was always hiding in there.
Okay, so if our laws are just evolving maps with cracks in them, that opens the door to a much, much bigger question. Let's peel back another layer of that onion. This is where things get really wild. Physicist Max Tegmark takes this idea to its most extreme conclusion, with what he calls the mathematical universe hypothesis. He argues that the universe isn't just described by math, he says the universe is math. That's right, everything you see, everything you are, at the most fundamental level, it's all just a giant, complex mathematical structure.
And this just puts two worldviews in total opposition. The standard way of thinking is that math is this incredible language we humans invented to make sense of the world around us. But Tegmark's idea turns that completely on its head. He says math isn't an invention at all. It's the literal fabric of existence, and our entire physical reality is just what it feels like to live inside that structure.
So you might be asking, well, if it's all just math, why does a chair feel solid? Why do I see stars instead of equations? According to the hypothesis, it's because our own consciousness is a self-aware piece within that mathematical reality. We experience a physical world because that is what it feels like for a piece of the equation to look at itself from the inside.
I know, it's a completely mind-bending concept. But whether reality is math, or is just described by it, we run smack into another huge mystery, the bizarre fact that our universe seems perfectly set up for life to exist.
The physicist Paul Davies has a great name for it, the Goldilocks enigma. You know the story, not too hot, not too cold, but just right. Well, when we look at the basic numbers that define our universe, the fundamental constants and laws, they seem to be tuned with incredible precision for life to arise. And the list of these just right conditions is honestly staggering. The strength of gravity, the charge of an electron, the properties of carbon. If you mess with any of these values, even by the tiniest fraction, poof, the whole thing falls apart. You wouldn't get stable stars or planets or chemistry. You wouldn't get us.
So, how on earth did we get so lucky? Well, science has two main and very different possible answers to this enigma.
The first idea is the multiverse. Think of it like a cosmic lottery. If there are countless other universes out there, each with its own random set of physical laws, then it's basically inevitable that one of them would happen to have the winning numbers for life. And of course, that's the one we'd find ourselves in. The second idea is the opposite. It says there's only one way the universe could possibly be. Its laws are unique and fixed, And it just so happens, by an almost unbelievable stroke of luck, that this one and only blueprint allows life to exist.
Now, both of these explanations are absolutely epic, but you can probably see the problem. Neither one is completely satisfying. One asks you to believe in a potentially infinite number of universes we can never, ever see. The other asks you to just accept a coincidence on a scale that is almost impossible to imagine. So, what's behind that final layer of the onion?
So are we just winners of a cosmic lottery, or are we an incredible fluke? This brings us to the most speculative, the most mind-bending, but maybe the most profound idea of all. It's an idea that connects the laws of the universe directly to you and me. Let's just challenge the biggest assumption we've made so far. We've been asking why the laws are what they are. But what if they weren't set in stone from the very beginning?
What if the beautiful, elegant order we see all around us today wasn't there at the dawn of time? What if it all sort of congealed out of the pure chaos of the Big Bang?
This is the radical concept of law without law, and it comes from the legendary physicist John Wheeler. He proposed that the laws of physics aren't these perfect, eternal rules that existed before the universe. No. He suggested they actually co-evolved with the universe, emerging and becoming more defined as the cosmos itself grew and changed.
Now, this sounds like pure science fiction, I know, but it's actually grounded in the certified weirdness of quantum mechanics. At the quantum level, reality isn't solid. It's a fuzzy cloud of possibilities, a mix of all the different ways things could be. Wheeler's idea is that in the super early universe, even the laws themselves were in that fuzzy state of possibility.
And here is the unbelievable twist. In the quantum world, the act of observing something now doesn't just tell you what's happening in the present. It actually reaches back in time and helps select which of those many fuzzy possibilities actually became real. Your observation today helps write the history of yesterday.
And this creates the ultimate feedback loop. Think about it. If the laws themselves were fuzzy and undecided in the early universe, maybe the arrival of conscious observers, beings like us, who look around and measure things, is what forced the universe to choose. We helped select the specific version of history, including the specific set of laws that was consistent with our own existence. In this view, the universe didn't just get lucky. In a very real sense, it may have conspired to create its own observers.
So we are left with this one final, truly startling thought. If the universe is a participatory system where the act of looking at it helps build it, then this story isn't just about the distant past. It's happening right now with every single observation. And that makes you wonder, doesn't it? What kind of universe are we all creating right now in this very moment?